When drivers or riders lose control of their vehicles and leave the road, there is a risk of injury and damage due to collisions with unyielding objects, such as trees and poles, or non-traversable features, such as drains or rough surfaces that may cause the vehicle to vault and become airborne, roll over, or stop abruptly. Ideally, the roadside should be forgiving, free of potentially hazardous features, so that an errant vehicle can be brought under control safely. The roadsides of most Indonesian roads are not forgiving. Too often they contain all sorts of public utilities and local beautification schemes. On many roadsides, you will see large posts supporting billboards or trees, or undrivable slopes dropping into rice paddies. A large part of the road safety problem in Indonesia is caused by the very limited control over development along highways. Inadequate control over land use and property access is increasing the number of potential hazards. Roadside safety is an important but overlooked part of road management in Indonesia. The safe management of its roadsides is an important responsibility of any road authority. Run-off road crashes are the largest single group of crashes on Indonesian roads. Data suggests that run-off-road single vehicle crashes account for 65% of all crashes on toll roads and 35% on non-toll roads. It is time to reduce run-off-road crashes. All it takes is some clear thinking by engineers and the knowledge about what to do. This DVD and the accompanying manual will give you that knowledge. Putting it to good use in Indonesia is now your task. A well-designed road aims to keep vehicles safely on the road. Safe road design and good maintenance endeavours to provide safe road conditions, including appropriate horizontal and vertical alignment, adequate road and lane widths, suitable crossfall as well as super elevation on curves, good sight distance, provision of clear pavement markings and delineation, provision of appropriate signing and road marking, a sound road surface, management of traffic conflicts at intersections, and appropriate management of vehicle speeds. The fundamental principle for designing safe roadsides is based on the knowledge that drivers and riders will make mistakes, and occasionally they will lose control and their vehicles will leave the road. We can never be sure exactly where or when this may occur. Roadsides need to be designed to eliminate, as far as practicable, the potential for crashes at any speed. Careful design can help to minimize the forces that humans will experience during a crash. With particular attention to safe design, it is possible to keep impact forces to within human tolerance levels at which serious injury is likely to occur. Safe design principles for the roadside area include provisions of a roadside that is forgiving in the event that a vehicle runs off the road. This is achieved by providing roadsides with a clear area that is free of hazardous fixed objects. This means all aspects of the roadside area should be designed to minimize the possibility of an occupant of an errant vehicle being seriously injured or killed. Roadside hazards are any features or objects beside the road that may adversely affect the safety of the roadside area. Roadside hazards are defined as any fixed object with a size of 100 millimeters or more. It also includes other features that are capable of contributing to a crash that could result in serious injuries to the occupants of a vehicle that runs off the road. Point hazards are permanent installations of limited length that may be struck by vehicles running off the road. The following items, when located within clear zones, are examples of point hazards. Trees over 100 millimeters in diameter. Bridge end posts and piers. Large planters. Hazardous mailboxes or landscape features. Non-breakaway signs. Inappropriate slip bases on signs. Protruding footings. Non-traversable driveway headwalls. Non-traversable culvert headwalls. Fixed objects in the drain line. Utility poles. Walls or corners of walls. Hydrant bases more than 100 millimeters high. Because of their limited extent, point hazards should, if possible, be removed from clear zones, rather than being shielded with a barrier. Continuous hazards differ from point hazards in that they are of a considerable length. It is therefore generally less practical to remove or relocate them. When located within the clear zone, they are considered to be hazards. Examples of continuous hazards include dense forests and woods, rows of large trees, drains, steep embankments, rock outcrops or boulders intermixed with trees, rock cuttings, cliffs or precipitous drop-offs, areas of water, unshielded hazards, retaining walls, fences with rails that can spear vehicles. Because of their length, continuous hazards often need to be shielded with a barrier. The objective of roadside hazard management is to manage the level of risk for a particular road for the benefit of errant drivers and vehicle occupants. It aims to address the risks and the consequences of roadside safety. Roadside hazard management involves a 5-part strategy to provide a safer roadside for new roads as well as road upgrading projects. The strategy can also be applied when improving roadside safety along existing roads. 1. Keep vehicles on the road. Keep vehicles on the road by providing delineation, warning signs, appropriate geometric standards, or other road design features. 2. Remove the hazard. Remove any existing objects and avoid locating potentially hazardous objects within the clear zone. 3. Relocate the hazard. Relocate existing hazards to beyond the clear zone to minimize the potential for them being struck or hit by an errant vehicle. 4. Modify the hazard. Modify or redesign roadside hazards to remove the potential for injury and severity of a crash. This includes, for instance, modifying rigid posts to provide frangible or breakaway posts. 5. Shield the hazard. Shield roadside hazards with safety barriers or crash cushions. These are designed to redirect an impacting vehicle and/or dissipate crash forces in a controlled manner. While it is preferable to remove, relocate, or modify roadside hazards, in some situations, shielding a hazard may be the only practicable option where it is not feasible or economically viable to treat the hazard in another way. Clear zones maintain a physical area adjacent to the road where hazards are managed in order to minimize crash severity. The clear zone relates to the part of the roadside, measured from the edge of the traffic lane, that is to be kept free of hazards so that safety is maximised for the occupants of errant vehicles. This area provides drivers and riders of errant vehicles some space to manoeuvre, or at least decrease their speed in relative safety when they leave the roadway. The clear zone distance that is used today provides a balance between a safe recovery area for 100% of errant vehicles, the cost of providing that area, and the probability of an errant vehicle encountering a hazard. The roadside hazard management decision-making process requires a structured approach to determine the clear zone at a particular location, and then examining the design and/or roadside area to determine if there are roadside hazards that require consideration. How you decide to treat hazardous objects or slopes that are within the clear zone will depend on a range of factors, including the type of hazard, the cost, the likely crash frequency and severity. In some cases, you may also have to consider environmental implications. The approach you take may also relate to whether a new or upgraded road is being designed, or whether safety deficiencies are being addressed on existing roads. Safety barriers, sometimes called crash barriers, are used to improve safety within the clear zone when roadside hazards cannot be treated by removal, relocation, or modification to improve safety. There are three main types of roadside safety barriers. Rigid barriers, which are generally made of concrete. Semi-rigid barriers, which are made of steel and include the common W-beam guardrail. Flexible barriers, which are made of steel cables and include various types of wire rope barriers. When you are selecting the type of barrier that will best suit your needs, there will be a variety of factors to be considered. These factors include performance capability and the level of containment requirements, clearance requirements to the hazard, and the dynamic deflection characteristics of the barrier, site conditions, vertical and horizontal alignments and cross slopes, compatibility with adjacent barriers, installation and maintenance costs, aesthetics and environmental impact. Although safety barriers are used to shield a roadside hazard, it is important for road safety engineers to recognize that safety barriers themselves are a form of roadside hazard. When considering whether to install a safety barrier, it is important to understand that the barrier will present a hazard to the occupants of errant vehicles. A barrier should only be installed if a crash into the barrier will present less of an injury risk to vehicle occupants than would result from a crash involving the roadside hazard that is to be shielded. Roadside hazards are one of the largest killers on the roads of the world. Many engineers in emerging countries such as Indonesia underestimate the importance of their work in reducing road crashes. Some of them think that crashes are only due to the faults and mistakes of the driver or rider. They believe that the only way to improve road safety is for police to be stricter and more effective with enforcement. These engineers fail to realize that many of the human mistakes that are made on the roads are in fact due to the failings of an engineer. You can improve the safety of roads, one small section at a time. You can help drivers and riders to avoid run-off road crashes by providing clear delineation of curves. You can help to minimize the severity of run-off road crashes by managing speeds and by installing suitable crash protection where needed. Engineers can make a difference. You can save lives and prevent injuries. By using the techniques contained within this series of DVDs and their accompanying manuals, you can influence the design, construction, maintenance and operation of safer roads. Engineers have a vital role to play in providing safer roads for all Indonesians. A clear zone is a drivable roadside area that is kept clear of hazardous objects in order to minimize the danger of a collision should a vehicle leave the road. A clear zone, adjacent to the roadway, provides a forgiving roadside area that reduces the consequences of a run-off road crash. Such an area may be needed where driver behaviour or deficiencies in the road design or delineation result in a vehicle running off the road. If the roadside is hazardous, an errant vehicle that runs off the road is at risk of a severe crash. The width of the clear zone needs to be an early consideration when you are designing a new road or during the design of a road upgrading. The required width of the clear zone will also be an important consideration during a road safety audit of an existing road. You need to know just how wide the clear zone should be so that you can start to take the decisions that will lead to it being developed. The clear zone width in design aims to provide a balance between the recovery area for an errant vehicle, the cost of providing that area, and the probability of an errant vehicle encountering a hazard. The clear zone should be kept free of fixed or non-frangible hazardous objects. Where this cannot be achieved, errant vehicles should be protected from running into these hazards by the use of an appropriate roadside safety barrier. In some design situations, fixed hazards cannot be avoided within the clear zone, such as bridge parapets, bridge piers, or trees that may have environmental significance. In these situations, the hazard needs to be shielded with a safety barrier designed to safely redirect an errant vehicle or to absorb the energy and enable an errant vehicle to stop with reduced severity to vehicle occupants. The clear zone width is determined by a process that considers a range of factors at a particular location. These factors are the speed that the vehicle is moving. At 60 kilometers per hour, 85% of vehicles will recover within 3 meters from the edge of the traffic lane. But at 100 kilometers per hour, 85% of vehicles will require 9 meters to recover. The traffic volume. A higher volume of traffic results in greater exposure and likelihood that a vehicle will run off the road and hit a roadside hazard. For very low traffic volumes, where very few drivers or riders are exposed to a roadside hazard, it may not be economically cost-effective to provide the full clear zone. The steepness of side slope. The slope steepness beside the road will influence how far an out-of-control vehicle travels. If the side slope is very steep, it will increase the risk that an errant vehicle will overturn. Adjustment factors are provided to increase the clear zone distance for roadside slopes.